Hello, I'm Paul Beckwith. I'm with the University of Ottawa Laboratory for Paleoclimatology. In this video and the next one I will be talking about global sea level rise and the ramifications of that to society, basically the source of most of this sea level rise, how much we're likely to have moving forward, and how it will affect global temperatures, and how it really means when global sea level rise is rapidly occurring. It is rapidly occurring, but when we get an acceleration in sea level rise, it will start really to impact global average temperature rise. And a better measurement, or metric if you like, will then be the energy imbalance, because massive amounts of sea level rise that are coming in the pipes will change the distribution of heating on the planet and will actually cool certain parts of the planet, which isn't a good thing. It will be that the heat energy is going into melting the ice on Greenland and Antarctic mostly to raise the global sea level rise. So I'm going to get the lights. Okay, so this is data from satellite sea level observation data, NASA Goddard Space Flight Center. It's from the early 90s to present day, and you can see that there is a variation from year to year. There was a dip here, and this dip was due to a lot of evaporation from the oceans, and the rainfall actually fell on land, and it took a while to get back into the ocean, so it caused this temporary dip. And right now we're looking at 3.41 millimeters per year. Very, very rapid rise. Doesn't seem like a lot perhaps, but you can see that the rate is, if you draw a line through here and measure the slope, and a line through here, and a line through here, you can see that the rate of change is increasing. In fact, it's increasing at an exponential rate. So let's look at an article from about a year ago about sea level rise. And what you can see here is basically, yes, the ocean is coming for us. Okay, so sea levels are rising about the 3.4 millimeters per year. And the average rate was about 1.4 last century. It says in just 80 years, the ocean could be a full 1.3 meter, which is 4.3 feet higher than it is today. Now, I will show you that the rise of sea level will likely be much higher than that. So keep in mind that the implications that are discussed in this article are 1.3 meters by 2100, but we're going to see this 1.3 meters much sooner than 2100. In fact, John Kerry discussed in Marrakesh in late 2016, the COP22 climate conference, that we could have 1.5 meters of sea level rise by 2050. And then there was some more recent data due to accelerated melt from the Totten Glacier in Antarctica, where that rate could actually be even double that, talking about 3 meters or 10 feet even by 2050. So I'll discuss that. But so keep in mind what will happen. This analysis here talks about only 1.3 meter, which is going to come a lot sooner than you think. So it's hard to fathom this kind of change unless you live in Miami or in a Pacific island where the effects are already evident. When you combine sea level rise with storm surges, with king tides, we're already getting massive flooding. And in fact, there's been severe warnings in the UK just now on the eastern part of the UK about king tides, and plus with the higher sea level and storms causing coastal flooding. So New Orleans, New York, Amsterdam, Calcutta, Bangkok, Tokyo, there's huge numbers of people living near the oceans. And in fact, it says here up to 260 million people currently live on land that will be below sea level or regular flood levels by 2100. So that's with a 1.3 meter or 4.3 feet sea level rise, it will affect 216 million people. So if this comes in decades as opposed to by 2100, then we're going to have massive migrations and massive destruction of infrastructure. So why is this happening? Climate change, anthropogenic, man-made, human-caused climate change, women are doing it too, is triggered by thermal expansion of seawater, is the main reason, as well as the influx of melting glaciers. So this is glaciers on Antarctica and Greenland. This is ice that's sitting on bedrock above sea level. When it melts, that water goes into the ocean, raising sea level. When you expand a fluid, the molecules are moving faster, they push apart, so you get this thermal expansion. People see this as a distant risk. You've got to get that out of your mind. You know, 1.5 meters by 2050 is not distant at all. Half of all humans now live within 60 kilometers or 37 miles of a coastline. This is not a niche issue. This will affect all of humanity. So let's have a look at some of the things that are discussed here. So global sea levels have already risen by 8 inches, which is about 200 millimeter since 1880. So this is showing measurements from 1880 to 2014. The brown line is measured by tide gauges that are situated on coastlines around the world. Of course, there's different local effects on different coastlines. Most people assume that sea level rises equally at all points on the oceans and on coast, but that clearly is not the case, because if the water it goes really, really hot off a coastline, that water will expand, the sea level rise will be higher. If the currents change, for example, the Gulf Stream ran ashore the continental shelf off the east coast of the US as it slowed down, and in 2010, 2011, the sea level rose about 125 millimeters off of the east coast of the US. That's about 5 inches in that season, basically, and then dropped off again. So there are different effects in local, but on average, these tide gauges show an increase, which is, you can draw a line through here, it's going up slightly. This is where we started measuring by satellite. This is from NASA's Earth Observatory. Not only are sea level rates rising, but the rate of their rise is rising. So here we are to the 3.41 millimeter. If you draw a little slope through here, you can see that the slope, you know, is actually on the rise here. So the rate of sea level rise is going up. From 1900 to 2000, the rise was 1.4 millimeters per year on average, and it reached 3 millimeters per year by 2010, and now it's up to 3.4 millimeters per year by late 2016. This rate is the fastest sea level rise the Earth has experienced in 3,000 years. So what this is showing is sea level rise in meters projected by 2100. That's with a global average of that 1.3 meters. So you can see that some regions have higher rises of sea level, other regions have lower rises of sea level for various reasons. So we can take this type of thing and amplify it about 3 or 4 times to get a more realistic number. Okay, so basically this rise is extraordinary in the context of the last 3,000 years, and over the last 2 decades it's been even faster. So the other thing to remember is, people forget this, every vertical inch of sea level rise moves the ocean 50 to 100 inches inland. This is because on the seashore, you need to take the slope, the angle of the shoreline. You know, if you've got a gently sloping beach into the water, then we'd be closer to 100 inches or higher. So an inch of sea level will go over 100 inches inland, whereas or, you know, if the coastline is sloped more sharply, then it would be 50 or some smaller number. So we're talking about vertical rise in sea level. This is an example of high tide on Miami Beach. Can't build a wall off Miami. It's based on limestone. Water just percolates through. Basically, you can't do anything to stop. When sea level rises, then Florida will be basically the real estate market along the Florida coast will completely collapse, and there will be mass migrations of people out of Florida into higher ground. So basically, there's already lots of flood problems in many big coastal cities. So you can go to this site and you just click on the particular images and you can see basically data on sea level rise in those regions. Another problem is that the seawater, as it goes over the land, it takes out the fresh water supplies over the land, and it can also contaminate the fields that are the agricultural fields that are close to sea level, and significantly decrease agriculture. There's these nuisance floods that are occurring more and more often. This is just with high tides or king tides with the existing level of the sea. Okay, so the frequency of those is increasing more and more. This is just showing areas that would flood are marked in red due to a 1 meter sea level rise. So you can see the coastlines that are mostly at threat here, and they basically go mostly around the planet. And this is just a 1 meter sea level rise. Remember, John Kerry was talking about 1.5 by 2050. Okay, this is saying up to 260 million people currently live on land that will be below sea level or regular flood levels with a 1.3 meter rise in sea level, which is about 4 feet rise in sea level. Okay, by 2100, I will show strong evidence that this will happen much sooner, perhaps even by 2050, and that we could have up to 5 meters by 2100. Actually, I'll talk about, I'm actually saying it's going to be even more. 7 meters by 2070 is very possible in my estimation. So of these people, of the 260 million people that would be in harm's way from a 1.3 meter rise in sea level, between 41 million and 63 million live in China. 12 nations have more than 10 million people living on land at risk from sea level. So we're talking India, Bangladesh, Vietnam, Indonesia, and Japan. Bangladesh is very vulnerable. In fact, it's the country most in danger from rising sea level. If a 1.5 meter rise will affect 16% of Bangladesh's land area, 15% of its population, so 17 million people and 8,500 square miles. Of course, low-lying islands are in great trouble, and they're actually buying land elsewhere and contemplating mass relocation. So this is how sea level rise can contaminate drinking water and irrigation water. As the ocean is rising, there's lateral intrusion of brackish water, which is basically the sea level, the salt water will be at 35 parts per thousand, or PSU units, practical salinity units, which is about 3.5%. So the brackish water is lower salt content, but it contaminates the wells, which are then used to irrigate fields and for drinking water. So as the sea level rises, there's more lateral intrusion, more contamination and coastal effects. So also coastal plant and animal life will be harmed, and many other factors will occur. So I'm going to continue on this video with multiple parts. So thank you for listening to the first part. Go to my website, paulbeckwith.net, for more information.